All right, so hopefully all of you got the memo before Wednesday's class. I put out the night before that was canceling class. We're using my room for dialogue days. So that homework assignment, I kind of pushed the due date up to be at the end of the week. All right, so instead of Wednesday by the end of the day, we've got until Friday by the end of the day next week to try to complete that. We'll go through kind of Monopoly stuff today, which probably you could get through every question on there after today's class. We'll finish up some other topics related to monopolies on Monday. So if there's a couple that maybe that's not quite as clear after Monday, those last kind of 2 questions or so, you could probably get through a little bit easier after Monday's class. But I was looking at today, I think the last 7 or 8 are related to Monopoly. You can probably get through, like I said, about 6 of them after today's class. Kind of the final 2 would probably be after Monday's discussion. Okay. Other than that, I still do have a bunch of corrections if anybody does want those, and I didn't get them back. I've got them, and you come and get them after class. But before we jump into things, are there any questions for me before we get started here? Okay. So I think where we left off last class was we were talking about kind of how we determine marginal revenue when we're looking at kind of a demand group, right? So the monopolist is the only person who's producing this good, right? So let's envision a world where they could choose the optimal price for this good. They can choose the price that would maximize their profits, right? Well, they kind of follow the demand curve and say, if we're charging $4.50, nobody's going to buy this good. If we charge $4, one person buys it, $3.50, we sell 2 units, so on and so forth. So you can calculate total revenue simply by multiplying price times quantity, right? That was kind of, we looked at it a couple times, but kind of think about total revenue here. That's just the number of units I sell times the price I sell them for. So from that total revenue, we can calculate things like average revenue. Average revenue would simply be, if I'm thinking about kind of average total revenue here, it's going to be total revenue divided by the number of units I sell or divided by quantity. So we could go through, once we have all those total revenues, where we simply multiply price times quantity, just divide those total revenues by quantity, and that gives us our average revenue. Now, to figure out marginal revenue, that's a change in revenue from a change in quantity, right? So anytime we're looking at something that's marginal, we're thinking about the change in that thing. So kind of the change in total revenue coming from a change in production, right, or an increase in quantity. Now here it's kind of nice because our changes in quantity are all 1 unit, right? We're just going up by 1. So that denominator is always 1 in this example. So really all we had to do was look for the difference in that total revenue, right, between each quantity. So going from 3 to 4, it gave us a marginal revenue of 1, 4 to 5. Total revenue doesn't change, so our marginal revenue is 0. So you can kind of see here, if I'm just maximizing revenue, right, that's going to be the point where marginal revenue is 0, right? My revenues are at their highest once I get to a quantity of 4 or 5. So sometimes you won't have just kind of 1 quantity that produces the highest value. You'll have 2 kind of quantities. But this is like things that we've kind of talked about with costs. We're just now applying that to revenue. Any questions over any of these 3 things? Okay, we're just, yeah.
We think about how you find
Yeah, so anytime we want to find average anything, average total cost, average fixed cost, average total revenue, you're taking whatever you want to find the average of, in this case, total revenue, and dividing it by the quantity produced. So if we look here, well, 1 unit's not very interesting. Let's look at 3 units. My total revenue would be 9. I've got 3 units. So on average, I'm making $3 a unit, right? Divided by 3. At a quantity of 4, my total revenue is 10. I'm selling 4 units. So on average, I'm making 10 over 4, or $2.50 off each unit. Is that clear up a little? Okay. Any other questions here? So we look at these different quantities. you can kind of see the marginal revenue is kind of declining, kind of flattens up at a certain point, hits zero, and then starts to become negative. So if marginal revenue is negative, that means as I'm producing more, I'm actually just eating into my revenue. That is decreasing total revenue. So we can think about graphing these two things. Right? So I've got my demand curve. I simply graph that by taking the price and quantity combinations here. So a quantity of 0, that was a price of 450, quantity of 1, price of 4, so on and so forth. I could then plot my marginal revenue, right? So at a quantity of 1, kind of between 0 and 1, the marginal revenue is 4, between 1 and 2, my marginal revenue was 3, and then kind of just graph that out as well. So what you can kind of see here, and I'll give you a little bit of a justification for why, but the marginal revenue curve is always below the demand curve. And what ends up being true is it's always twice as steep. So notice my price was falling by 50 cents every time I went up by unit. My marginal revenues were falling by $1 when I went up by every unit. So twice as steep. They were falling twice as quickly. So the monopolist is trying to find the price and quantity combination, right, based on this demand curve, where he's going to maximize profits, right? And he's going to be able to make a decision, that decision here in a second, using that marginal revenue curve. So with perfectly competitive firms, he said they chose the optimal quantity where marginal revenue is equal to marginal cost. It's just that for them, they had kind of this nice marginal revenue curve where it was flat, right? Because they used to take the price of given. The monopolist doesn't, because it's not a competitive market. He can choose whatever price quantity combination that they want. So why is it twice as steep? So kind of using this pi, this Greek symbol that we use to kind of for notation for what profits are, right? So anytime we see this P, anytime you're thinking of, or this pi, we should be thinking about profits. Well, we know that that's going to be, oh, sorry, I'm jumping the gun. I got to show you something. I can show you that. Sorry. Let's take a step back from profits. Let's just think about kind of total revenue. So total revenue, which is a component of profits, right? But total revenue itself is just price times quantity. Number of units I sell times how much I sell for. For this price, right, we think about the way that we typically see our demand curve, right? Our demand curve usually is some intercept and then a negative slope, right? So that as we increase quantity by unit, like we see our kind of demand curve decreasing by whatever that slope is, right? Go all the way back to kind of our mathematical representation of the demand curve. It looks something like this. It will have an intercept and it has this negative slope. Well, when I'm trying to maximize total revenue, if I know that kind of the price that people are willing to pay is based off of this demand curve, demand equation, or demand curve, I could plug that in for price, and my total revenue curve or equation looks a little bit different. But it's still representing the same. It is plugging one equation into the other. I know that the marginal benefit, remember demand, this price really is reflecting marginal benefit. So the amount that people are willing to pay up to that amount is going to follow this relationship or follow this equation. So I can just plug that in. So I'm not expecting that anyone has gone through calculus here, but the idea, in case you have, right? The idea behind what we're doing is we're essentially saying, okay, I want to choose the quantity that maximizes total revenue. So I want to look at kind of my change in total revenue, or kind of take a derivative of total revenue with respect to this thing I'm choosing, which is quantity. Well, if I distribute out that Q, I'll end up with something like that. And if I take the derivative of this function, since this is squared, I bring the 2 out front. And notice we end up with that kind of my marginal revenue, or how much my revenues are changing from a change in quantity, is just my demand curve but twice as steep. Now, this only works because we're only using linear demand. If we start to have demand that has a little bit of kind of a different formula, it won't always be twice as steep. It will be steeper, just maybe not twice as steep, but because we're always going to be using just this linear demand curve, for us, we know that the marginal revenue curve will always start at the same point as the demand curve, right? Same intercept. But the slope, right, instead of being B, will be 2 times B. So it'll be twice as steep. And we saw it kind of play out with the numbers here, right? Demand was falling by 50 cents each 1 unit increase, and total revenues, sorry, not total revenues, marginal revenues was decreasing by $1, right? Twice as steep. Any questions on that? We're thinking about kind of taking a derivative, that total revenue function that gives us marginal revenue. And even if we don't understand the calculus, that's fine. Kind of see, it'll always be twice as steep. Yeah. So, well, I guess we got the answer. We can kind of work through this together, I guess. All right. So let's say, I mean, we see the answer is 5 here, but why is it 5? So one of the marginal revenue, if we're increasing quantity from 6 to 9 units. So here we've got all these different quantity combinations and the different prices associated with them. So these price quantity combinations are essentially telling us where our demand, like we could use those points to plot out our demand curve. I then also gave you kind of the total revenues, which how would I have found those total revenues? Simply price times quantity, right? So 10 times 0 is 0, 9 times 3 is 47, 8 times 6 is 48, so on and so forth. Now this marginal revenue column, I don't have completely filled out, right? But I can think about my marginal revenue equation is just a change in total revenue from a change in quantity. So if I'm moving from 6 to 9 units, how much do my revenues increase by? Not my revenues don't increase by 3. Now my revenues going from 6 to 9 units go from 48 to 63, right? So my change in total revenue there, 63, what I forgot what it was, 48 or 15. What's my change in quantity? Someone said that earlier. Well, I was going from 6 to 9, so that change in quantity is 3. So my marginal revenue moving from that 6th to the 9th unit, and I don't know why in this scenario, right? This is just a good word. For whatever reason, our production increase is happening in batches of 3. Maybe this is a product that, you know, they package it up in 3 units at a time, right? So my total revenues go up by 15. My quantity changed by 3. So 15 over 3, we get a marginal revenue of 5. And that's where the marginal revenue is 5. So this is an example where we didn't just have 1 unit changes in quantity, so we had a little bit more math to do. What's the marginal revenue moving from the 12th to the 15th unit? So my change in total revenues is what? 3. My change in quantity was 3. 3 divided by 3 is 1. So we can figure out the marginal revenue each, hopefully, for each one of these kind of quantity movements as well. Any questions here? Because like this is kind of really building out of a pretty easy base here, but I want to make sure we're okay here before we kind of keep continuing into this. Okay. So we think about when the monopolist is trying to choose the optimal price and quantity, as they increase quantity, 2 things happen. 1, total revenues go up because we're increasing quantity, right? But as I produce more and more, right, I know that people are going to be willing to pay less and less for the additional units, right? So I've got quantity kind of pushing my revenues in one direction, price is pushing it in the opposite direction, right? So where's the optimal kind of price quantity combo, right? Well, if they're facing, right, the entire demand curve, which that's telling us that if I want to sell more units, I'm going to have to lower the price, There's something we've already talked about. We could actually determine the point on that demand curve that would maximize total revenue. So we're thinking about quantity is pushing in one direction, price is pushing in the other. We can start to think about percentage changes, right? And which one of these is greater? Well, that depends on the elasticity of the demand curve. So, I want to go to this slide. So I'm going to draw this out to kind of explain it a little bit better than what I have in the slides here. So if we're looking at this monopolist, he's facing the entire demand curve, right? And the marginal revenue curve will be twice as steep. Okay? So one thing we had talked about before with elasticities was that if I'm thinking about my demand curve and I want to map those different quantities to total revenues, we said the point where total revenue is maximized was where the percentage change in price was the exact same as the percentage change in quantity. Right? And that was the point on our demand curve that was unit elastic. Now, when the percent change in price was the same as the percent change in quantity, kind of that quantity increase was equally offset by that price decrease. Quantity increase improved profits, price decrease would kind of decrease profits. So when they were the exact same, we said that, okay, profits aren't changing. Well, we're not thinking about profits here, we're just thinking about revenues. So the revenues wouldn't change because we haven't factored the cost yet into our scenario. So we know that total revenue is maximized at this unit elastic point. And what's going to be true at that unit elastic point? Well, if revenues aren't changing, we can kind of think about that's the point where the change in revenue or marginal revenue is zero. So at the unit elastic point of the demand curve, we know that the change in revenue or marginal revenue is zero. So if we continue to increase production as a monopolist, in order to do that, we're going to have to decrease the price. We're actually just decreasing revenues past that point. So it makes no sense. We know that costs are increasing with production, right? So once we get to the point where marginal revenues are no longer positive, well, now we're just increasing costs and decreasing our revenues. So we're definitely not going to be on that part of the demand. So if we're not, turn around. For a monopolist, right? This inelastic portion of the demand curve, we never want to end up there because we know that corresponds to quantities where marginal revenue is negative, right? Or we'd just be decreasing our total revenues. So the optimal point is going to be kind of somewhere on this elastic portion of the demand curve, or potentially, theoretically, right up to that point where it's inelastic. So we're using something where we talk about elasticities to understand that this monopolist, right, when choosing the price quantity combination, would never want to be on this inelastic portion of the demand curve. And why is that? Well, we said when it was inelastic, that's not very responsive, right? So if they're on this inelastic portion of the demand curve, right, as I'm decreasing the price, right, it must be that that decrease in price, the percent change in price in the denominator, is larger than the percent change in quantity. So that percent change in price will drive down my total revenues by more than that increase in quantity will, if it's inelastic. Any questions on that before we keep moving here? Okay, so with this in mind, where is the monopolist profit maximizing point be? So we can identify here the revenue maximizing point, but it kind of depends. We know how quickly marginal revenue is falling, so it depends on how quickly marginal costs are increasing, right? And kind of where that optimal combination of the two is going to be. As we said, really, you can think about the change in profits is just going to be the difference between the change in my total, the change in profits is going to be the same as the difference between the change in my revenues or the marginal of revenue, difference between that and my change in cost from the change in quantity or my marginal costs. Right? So now we're going to take marginal revenue. We're also going to build in marginal cost as well, determine what that profit maximizing point is. So I kind of mentioned earlier, in the perfectly competitive market, we said the optimal quantity that was chosen by the firm. So we're thinking about here, this was the optimal quantity the firm was going to choose, would be where marginal revenue was equal to marginal cost. It's just that it was easier because marginal revenue we knew was just whatever the equilibrium price was, and it was kind of constant. Well, the monopolist is actually going to make their optimal quantity decision based off of the same rule. It's just that theirs is going to look a little bit different. So for a monopolist, we're thinking about kind of the quantity that they're going to choose. They face this demand curve. We know that marginal revenue will start at the same point, will be twice as steep. We'll have our kind of Nike swoosh marginal cost kind of curve. And then I'll choose here, I'll show you this scenario. So let's say that's where their average total cost curve is. So they're going to choose the quantity that will maximize profits is where marginal cost is equal to marginal revenue. For every quantity below that point, the marginal revenue of producing that unit is greater than the marginal cost. So the amount I'm adding to revenue is more than the amount I'm adding to cost, so my profits should be increasing. You kind of think about the change in profits for all those quantities. Well, if marginal revenue is greater than marginal cost, the change in profit is positive, profits are going to be going up to the point where those two things are exactly equal to each other. Okay? So I'll kind of call this MON, or you could just write out the entire word. That's the optimal quantity of monopolist is going to choose. Now, at this quantity, instead of charging this low price, they know that that last unit, that there's someone out there who would benefit, whose marginal benefit to consuming that unit would be whatever point we're at on that demand curve, right? For that last unit provided by the monopoly, people would be willing to pay whatever point we're up here on at the demand curve. I said that was all kinds of wrong. Whatever point we're on the demand curve at that quantity, right? So our equilibrium price is we take that optimal quantity that the monopolist chose, go up to the demand curve, and that would be the price that people would be willing to pay for that unit. So just like a perfectly competitive firm, they choose the quantity where marginal cost is equal to marginal revenue. Once the optimal quantity is chosen, we just go up the demand curve to figure out how much people are willing to pay, and that would be kind of the price that they pay, right? The point that we're at on our demand curve. This kind of wording lines up with this graph. So, what do I have here? I don't think I want to. What else? Did we not talk about any of this? So less than the price, lower than the demand curve, down so. So this is basically what I kind of said earlier. Like, the only thing we really need to know about the monopolist marginal revenue curve is, yes, not only is it always below the demand curve, but it's always going to be twice as steep, right? And we talked about some other features like, the portion where it's elastic is going to be where the monopolist wants to choose the quantity. They'll never want to take the quantity past the unit elastic point because we said marginal revenues are all going to be zero. Well, if marginal revenues are zero, our costs have to be something. So the change in profit at any point, at any point where marginal revenues are negative, we'll definitely just be eating into our profits. So we'll definitely choose a quantity somewhere well before that. Now, from what we talked about with perfectly competitive markets, once we understand how the monopolist chooses this kind of quantity price combination, what's going to be true about profits here for the monopolist? Going to be positive, negative, or zero? So profits are going to follow the exact same equation the monopolist did for the competitor, right? So it's just the quantity they sell times the difference between the price and the average total cost. So if I'm looking at this graph, what's true about that relationship between price and average total cost? Yeah, at this quantity that I've chosen, price is above my average total costs. So we can kind of think about the difference between the two would give me the height of my rectangle, right? That represents this guy. And then the number of units I sell is just going to be the width of that rectangle. Simply multiply the quantity times that difference in price and average total cost, and we would see that we have positive profits because the price is above average total cost. So what if, I can probably jump in the gun here a little bit, but I think this is, I might be thinking a little odd. Make sure what I have next. So we have this up on the board. Right, this is how we choose our optimal quantity, then we go up to find our optimal price. So are we okay with this? Or are we not okay with it? So I guess really the only difference that we have between a monopoly and a totally competitive firm is that instead of having this kind of constant marginal revenue, our marginal revenue is going to change because we can choose the price from this demand curve, right? So if we choose this price quantity combination on the demand curve, we know that our marginal revenue down here, or we know that whatever point we choose, the marginal revenue will always be twice as steep. So when we're drawing this out, when we're looking at these kind of equations, we probably won't do much of the equations yet, but I'll know that that demand curve is always above marginal revenue, and the marginal revenue is twice as steep. So if I want to ignore even for a second average total costs, like I could draw that out here real quick. We'll draw underneath my perfectly competitive market, right? So they're choosing quantity. We always know they're going to have some marginal costs. Here's the demand curve. Now, actually, what's a kind of a weird thing with monopolists, if I know their marginal cost curve, I actually know the market supply, right? Because they're the only one who's supplying that good. Remember when we were looking at overall market demand and market supply, we said market demand reflected marginal benefits of those last units sold. Supply represented the marginal costs of those last units sold. So if I have a monopolist marginal cost and they're the only producer, that actually is reflecting to me the supply curve. So if I allowed this market to be perfectly competitive, I would actually choose the point where marginal benefits equal to marginal costs. But right, these are the marginal benefits of the consumer. So when the monopolist is looking at this, he's not going to be using the marginal benefits of the consumers to make his decision, or her decision, its decision, rather, shouldn't give it a pronoun there. But the monopolist is going to say, okay, look, I know that my marginal revenue curve is twice as steep, and that represents my marginal benefits, right? So the monopolist doesn't care about the marginal benefit of consumers. They care about their own marginal revenue, their own marginal benefit. Right? So they will choose the quantity such that at that last unit produced, the marginal revenue of that last unit is exactly equal to the marginal cost. For every quantity before that, the additional revenue was well above the additional cost, right? So we kind of said we do something, we decide to purchase something, we decide to, to buy the next unit of something as long as the marginal benefit is greater than or equal to the marginal cost. For every unit down here, the marginal benefit, the monopolist or marginal revenue, is way above the marginal cost. Right up to this last unit where they're exactly equal to each other. Kind of continue to go past that point. Well, now marginal costs are greater than marginal revenues. So change in profits would just be negative, right? Be eating away profits. So once we choose that optimal quantity, the other difference was, well, before I never had to worry about finding the price on a perfectly competitive market, right? Because the equilibrium price just was what it was, right? The firm had no control over it. Well, now the monopolist says, okay, at this quantity, I know that the amount of money that the last person purchasing it would be willing to pay is reflected by the demand curve, because the demand curve reflects my consumer's marginal benefit. So at that quantity, the demand curve tells me that at that quantity, the last kind of unit purchased would be wherever I'm at in the y-axis there. And so I could set the price as high as that, and I know that every single unit will be purchased.
Is that ever a good thing?
That every unit is purchased. So if we're thinking about something like supply chain issues, and obviously not, if we're just thinking about, maybe this is more of a long run kind of projection where I know that there are enough consumers willing to kind of purchase all these units. If I want to produce some because I'm concerned about supply chain, it makes it a little more complicated. We're kind of assuming that away right here. We're just saying, if we were trying to determine what the optimal quantity price was in this kind of short run snapshot, right, then we would want to set the price such that we sell everything we produce. I mean, in the long run, even a company, right, that is your goal. Now, the intermediate steps to make sure that you have enough of supply at different times, so you're not seeing these huge price fluctuations, stuff like that. Yeah, you might want to even out kind of your supply, but right, your end goal is, well, whatever I'm producing as a company, I don't just want to hold on to it forever, right? So yeah. Good question. Yeah.
So the top dot, that's where is you can sell it like at the most that people will still buy it, and the bottom dot is where you can.
The bottom,
sell
so
it the least.
yeah, so that bottom dot doesn't necessarily represent anything about the consumers. So this is just going to be the bottom dot like happened first, right? We identified this point so we could figure out the optimal quantity, right? The point where marginal revenue is equal to marginal cost. So that was like that bottom dot goes with it almost like label it. Put a 1 here, then 2 here, right? I first have to figure out where marginal revenue is equal to marginal cost, so I can determine the optimal quantity. And the second step is at that quantity, figure out where I'm at in the demand. And then once I figure out where I'm at in the demand curve, that reflects the price that I'm going to set for this good. Profits, the relationship doesn't change from what we were talking about with a perfectly competitive market. We're just going to say, okay, at the quantity I'm producing, what's the price that I'm charging, and what's the average total cost of that unit. The difference between those kind of tells me the sign of profits, right? If price is above my average total cost, well then on average, I'm making more money on each unit than what it's costing me to produce, so I'll end up with positive profits. If price ever falls below average total costs, well now for every unit I sell, on average, I'm making less money than what it's costing me to make it, so I'm going to end up with negative profits if that's the scenario. Any other questions here before we keep moving? So, I guess I just didn't turn on any of my animations today, so we'll see if one of these I remember too. So we can kind of think about the relationship between things here. When we choose this optimal price quantity, notice this price. In this scenario, it's above average total, but you can imagine potentially if my average total cost curve was up here and I face the same demand, I could end up in a scenario where price is below average total cost. But what will always be true is this price, the point that I'm add up on the demand curve, well, that's always going to be above where marginal costs and marginal revenues intersect, right? And that's just a byproduct of the fact that the marginal revenue curve is twice as steep as demand, right? So I know that my price will always be above my marginal revenue compared to marginal cost, or at least the marginal revenue, marginal cost of the last unit provided or last unit produced. Right? So the marginal revenue, marginal cost of that last unit produced is below that price I'm going to charge. So I think that's kind of where we can get this, right? Marginal revenue and marginal cost of that last unit produced are exactly the same, so they're equal to each other, but they're both less than the price that the monopolist is going to choose. Any questions on that? Okay with this? Yeah. No, questions, I mean,
What did we need to, like, why do we need to know the part that you shaded in?
so that was kind of representing our profits, right? So we think about what that shaded area represented. We know that our profit equation is going to be the number of units we sell multiplied by the average difference of how much we're making, the price, and how much it's costing us on average. Well, at this quantity, I know the price now, right? And I'm at my average total cost curve at this value. So the difference between the price and average total cost, that's the first part of my profit equation. That's the height of my rectangle. And the number of units I sell, I guess I should label this, right? I'm going from 0 to whatever point it is. That's the second component. So if I take Q times the difference between P and ATC, or the price and average total cost, that area is going to reflect profits. And that's the same thing we did with a perfect competitive market too. So nothing new that would have to do differently for the monopolists. So I guess I just didn't turn any of these off. We'll see what we'll do. That we might work through some of these. We'll work through these, and I think I have one thing I want to make sure I show you today. So we've got all the answers here, which doesn't really help us, but we can at least work through why they are what they are. So what if I had asked you from this information, how much should the monopolist produce if the marginal cost is constant at $5? So sometimes we'll start using these examples, especially when we start looking at natural monopolies, or government regulation of monopolies, just to better understand them and to kind of simplify the model. But if I have constant marginal costs, all that's really going to change. So anytime I draw something that reflects a monopolist, I should kind of start out with this downward sloping demand curve and a twice as steep marginal revenue curve. So all I'm saying here is, what if instead of increasing, we had constant marginal costs? Not really the most realistic scenario. We know that even if they were increasing very slowly, we should see kind of, from diminishing returns to our labor, we should see an increase in marginal cost. But to simplify things a little bit, sometimes I'll give you constant marginal costs just to make it a little easier. So what should be true is, even if marginal costs were constant, we're going to choose that optimal quantity wherever marginal cost is equal to marginal revenue. So if I'm looking up here and I start going down from the quantity of 0 to 5 to 10, I'm looking for where that marginal cost of what? $5, which is constant. Where is it equal to my marginal revenue? So I look at going from that 0 to 5th unit, marginal revenue is 9. 5th to the 10th, marginal revenue is 7. Going from the 10th to the 15th, marginal revenue is 5 there. So producing those 15 units, going from 10 to 15, my marginal revenue is exactly equal to my marginal cost. So we say that firms are indifferent at that point, but instead of saying indifferent, when we're kind of identifying the optimal quantity, we say, okay, when they're equal, that's where we'll stop producing. And it kind of makes sense in the context of, like, if we were able to disaggregate the quantity a little bit more, we'd actually see that going from the 10th to the 11th, the marginal revenue would be a little bit higher. And so we actually would want to produce all the units within this range. But if for whatever reason, in the context of this example, if we're only able to produce things in blocks of 5, then I would want to make sure I'm going from 10 to 15, because for every unit in between that range, the marginal revenue, right, is going to be above my marginal cost of $5 up to that very last unit where they're exactly equal to each other. Right? When marginal cost is exactly equal to marginal revenue, going from that 10th to that 15th unit, that's where I'm going to stop production, or the optimal quantity there would then be to produce 15. If I were to continue, right, if I wanted to go instead increase my production from 15 to 20, well, now the additional revenue of those 5 units is less than the additional costs. So I'm just adding more to my costs than I am to my revenues, or I'm just eating into my profits. Okay. Questions on this? Let me see if I gave you a total cost on here. So one thing, I'll point out one more thing here, kind of related to this data. So I'm telling you that 15 units is where profits maximize. But if it's easier to think about profits in a slightly different way, which is just total revenue minus total cost. So I've got my total revenues up there, right? Yeah. But I don't have my total costs. Well, if marginal costs are constant, right? And we assume that we have no fixed costs, it was gonna be just marginal costs in the long run. Then my total cost should just be that marginal cost, which we said was $5 times however many units I sell. Right? If marginal cost is constant, which in this case it is. Total revenue would be kind of price times quantity. And so I've got values for total revenue in that column. So if I look at units of 5, right, what would my profits be? So I look at that quantity of 5, total revenue is 45. Minus 5 times that quantity of 5, so what? This ends up being 20. So this was when my quantity was 5, 10, 15, and we'll go up to this 20. Right? So my quantity is 10. What are my total revenues? I can't see it. 80. Okay, 80. My marginal cost is 5 times 10 units. So my profit is 30. When quantity is 15, my total revenue is 105. Marginal cost of 5 times the number of units I'm selling, 15. It's going to be what? 50, 75, so 30. Okay. Quantity of 20 is 120. Minus 5 times 20. So it's 20 here. So remember, when marginal revenue is equal to marginal cost, it's almost like the profits aren't changing. So notice, going from that 10th to that 15th unit, so profits didn't change at all. And that's because the marginal revenue is exactly equal to my marginal cost. Now I'm doing this in batches of 5. Obviously, like when it comes to most production profit, you can choose like quantities by 1 unit. But this is just kind of showing what if we had to go up by 5. You can see here profits are increasing, or at least they're not decreasing up to that quantity of 15. If I go to any quantity higher than 15, I can also see that my profits are decreasing. Right? So I know that my profits are maximized right at that quantity where marginal revenue is equal to marginal cost. Now, we could say that people are indifferent, or the firm here is indifferent between choosing a quantity of 10 and 15 because profits would be the same. So the practice is, and we're just identifying it, like all these problems we're working through, we'll just choose that quantity where marginal revenue is equal to marginal cost. That'll be a fail-safe way to ensure that profits are at their highest point. In this scenario, we had a quantity jump where profits actually remain the same, but in some scenarios, like there's no kind of leveling off. There is a point where it's only the kind of combination that has the highest profit. So by choosing this point where marginal revenue is equal to marginal cost, we're always guaranteed that we end up with the highest value. But in some scenarios, there'll be like another one that's tied with it. Any questions over anything there? Kind of just a different way of thinking about why profits are maximized when marginal revenue is equal to marginal cost, seeing it kind of play out in a different way. So what if we had marginal cost be $0? Well, then if I'm looking here, I would want to choose as long as I would want to produce that quantity as long as marginal revenue was above 0. Notice for all these quantities, marginal revenue is above 0. Going from that 25th to the 30th unit, marginal revenues then become negative. So I actually want to stop at that 25th unit. So even when marginal costs are 0, right? It's not that we're just going to increase the quantity as high as we possibly can. We're going to increase our quantity. I erased it, but we increase it up to the point where marginal revenues are equal to 0. If we had 0 costs, right? 0 marginal costs, which is like a theoretical like thought experiment, right? We're never going to see marginal costs probably be exactly 0, even if they're really, really low. But even if they were 0, we would only go up to that point where marginal revenue is equal to marginal cost. If the marginal cost is 0, it will be a marginal revenue is equal to 0. Okay? All right, so I think I'll save this. Where we got in time? I'll save this for Monday. But I want to go through one more thing. So first of all, I want to see if I can I want to see where your guys' heads are at on this. So try to be thoughtful about your answer. But let's say that the monopolist faces the entire demand for a product, right? So if I have a monopolist of maybe electricity in a certain area, anyone who wants electricity has to buy it from this monopolist. So they face the entirety of the demand. Okay? Let's say that's the scenario, and they're currently earning positive economic profits. Right? Well, if there was no barriers to entry, potentially, right, another firm tries to enter this market because it looks at the monopolist and say, hey, you're earning profits, I want a little piece of that. Right? So if a second firm enters, what's going to happen to the existing monopolist who is already in the market? Well, they no longer face the entire demand curve. They have to share it with this new firm, right? So even if they were still able to act like they had monopoly power, when this second firm enters, automatically, let me see if I can get a good where I want this to be. I think at a point, I'll just draw it real extreme. So let's say demand falls by half, right? Because they're now sharing demand with another firm, right? There's two firms who are now splitting it. Well, now the optimal quantity, still where marginal revenue is equal to marginal cost, just now I face a lower marginal revenue curve. So we can kind of call this Q2. I'll go up to my demand curve, set the price, call this P2. So after this new firm, the second firm enters the market, my price is way below average total cost, right? So here we kind of think about my average total cost is way up here at ATC2. You don't have to just take one closest. Well, now my price is below average total, so I know that profits in this green area will actually be negative, right? Because the price is below average total cost. So this would be a scenario where we call this like a national monopoly. There's only enough demand to support one firm. As soon as a second firm enters, what happens? Well, now both, like this would reflect both firms, they now have negative profits, right? Assuming they have the same cost, right? They'll have negative profits. If there's negative profits, then in the long run, what does one of those firms do? They leave the market and we're back to a one firm monopoly, right? So there are markets like this. Really, this would be like either something about the cost structure. We'll take a look at that reasoning next week. It's like if you have really high fixed costs, potentially you only have enough demand to support one firm. Or if you have a good where demand just isn't very high, right? If demand isn't very high for this product, potentially you could see a scenario where there's only one provider of that, right? So if you think about, some of this stuff like collectible items, I think about like there's pretty low demand. So if you think about there's sometimes in any one area, you only see like one comic, like comic book store or a trading card store, like all these kind of things that there's not a huge demand for. So probably reason there's only ever going to be one provider of that. So this would kind of reflect that. So we went through a lot of the kind of topics of monopolies. We'll cover a few more on Monday. We'll look at natural monopolies. That should give us kind of like enough. We kind of finish the last two problems of the whole assignment after Monday's class, but we should be able to work on what 22 of the 24 up to this point. So that's going to be due next Friday at the end of the day. I pushed that due date up a little bit. So start working on that early. Come to me early next week with questions if you have any. Feel free to email me. I'd like to see more of you in my office, especially if we're kind of having some difficulties with some of the work. Other than that, have a good weekend. I'll see you guys on Monday. Oh, yeah, sorry. For the eye clicker before you leave, I opened it up and I got going and forgot. So just kind of respond with any letter just so I can kind of have you mark it today after everyone. Make sure you put, hit your eye clicker on your way out. Happy weekend, and I will see you on Monday.